I thought I'll just start by if you could sort of just tell us a bit about how CacheFly was, when it was started, how it was started, and why.
Sure. So CacheFly got started in 2002. This was right in the. How many people are generally familiar with the CDN marketplace? No, Akamai. Okay, so most people. So Akamai had just acquired a company called Speedera, who was kind of the #2 player in the space. And I was working in Phoenix at the time. There was a company called Limelight starting, and I kind of got offered a job there. And what Limelight really wanted to do was build a network. That was their background, and they thought CDN is the new cross connect. It's a great way for us to just get bits onto our network, and that's what we want to be. And at the time, I kind of thought, well, actually, I think CDN is the new CDN. That's probably what you want to be doing. You really don't want to be running a network. So we agreed to disagree. A $500 million IPO later, their way definitely did not work. But I kind of started CacheFly after that conversation, seeing the kind of spot in the marketplace. So that was 2002. A couple of years we spent just kind of getting a feel for what technology we wanted to deploy, how we wanted to do the geo, what our software stack was going to end up looking like. So 2005 we launched CacheFly as the product brand. So just a little over 10 years ago. Very early on, we all of a sudden kind of fell into hosting some pretty popular podcasts, or videocasts, which at the time had just started. So we hosted a show called Dignation, which was kind of the #1 show on iTunes for a very long time. And we learned very quickly about the iTunes effect, which was, at the time, there was not really much logic in what iTunes was doing. So as soon as anybody updated their RSS feed for their podcast, all of a sudden you had 400,000 Dignation subscribers all coming to get the latest MP3. So we kind of learned to scale as Dignation scaled, which was very quickly.
And from there, we just kind of took that market. We're still very popular in the podcasting video hosting space. And today we have a little over 3,000 customers. We've got everybody from Fortune 50s to small mom and pops, podcasts, everything in between. And yeah, so our software stack started as, we were FreeBSD, for the FreeBSD shout out. We actually wrote the original KQ handler in light HTTPD.
Wow.
So that was 2004-ish. Ultimately transitioned to Linux and ended up for the last 10 years or so on kind of a hybrid, a little homegrown, a little open source. We have some Nginx, we have some Squid. Now, as of the last year, we have quite a lot of Varnish cache as well.
Cool. So you've been in business for almost 15 years.
Yep.
So during that time, I mean, you obviously mentioned podcasting sort of has had a significant impact on you. Mm-hmm. And I think as a long-time Twit listener, I've sort of been, I think, familiarized myself with the brand very early on. Mm-hmm. Has there been sort of other external events that have sort of influenced the way you do content distribution?
The big one was, in addition to that, would probably be everybody's transition away from Flash for video and RTMP towards HLS and HDS. We kind of made a conscious decision very early on that we did not want to be doing RTMP. We only wanted to deal with HTTP, and that kind of left us out of the live video streaming game. So we even had a lot of customers that would use somebody else for live, and then they'd host archive on us.
Yeah. Because archive was FLV?
Either FLV or MP4, yeah, whatever it was. Mm. So as everybody has shifted toward HLS and HTTP-friendly streaming protocols, we've seen a huge influx in people doing live stuff on us now. Okay. And so that we kind of had to re-architect our back end a little bit to start supporting kind of more on-demand ingests on the CDN side. And that actually is kind of what led us to deploying Varnish Cache last year.
Okay, yep. So obviously the sort of, from the sort of network side, is HLS a lot friendlier towards the network than the previous sort of video distribution mechanisms?
From our standpoint, it is.
Yeah.
I'm not necessarily sure I would have the same answer if I was running a mobile network or something, because RTMP did obviously very different, but a decent job at trying to figure out the right bit rate to deliver video at. With HLS, it's obviously that's offloaded to the client, so you're kind of relying on how Apple wants to do it in the case of HLS. And if you don't like the way Apple does it, you're writing your own client or you don't really have a choice. So there's a little less control, but it's definitely friendlier for all CDNs. It's a very easy protocol to cache because they're just files.
Yeah, I heard that that if you're Facebook, you can actually get away with not using HLS, but if you're anybody else,
yes, then
you sort of you're stuck with HLS.
Yeah.
Okay. So we don't run any sort of content distribution ourselves, which is sort of for us getting somebody like CacheFly to sort of run our software is immensely valuable, because we sort of sit in our office all day, make all these sort of assumptions about what the world is like, and then we sort of write software on that for 18 months, and then we sort of put the software out. And so for us, sort of getting Matt to sort of try out the software early on was I would say extremely helpful in sort of both in sort of the bugs that you sort of managed to discover, but also sort of in the sort of building the sort of confidence that we needed in order to push the software. So one thing that sort of at least from the outside seems to be, I would say, a rather intimidating aspect of running a content distribution network is security. First and foremost, sort of to have the constant threat of denial of service attacks affecting the network. Could you tell us a bit on sort of how you live with this, and sort of what sort of countermeasures you use, and how frequent it is? And
Sure. So I do another show of hands. We like to show of hands things. Who's ever been a part of mitigating a DDoS before, or actually a decent number? So the thing you kind of find is as you have more infrastructure scale, it generally just gets easier. So the big benefit that CDNs have, or somebody like Cloudflare, is we just have lots of ingest points. So we do Anycast, or TCP Anycast for the CDN. Most CDNs launched in the last 10 years or so, except one, are all doing Anycast. And the nice benefit of that is you're kind of letting your network architecture dictate where that attack is going to come in. Everybody kind of assumes it gets equally distributed. So like, oh, if there's a 100 gig DDoS, then there's 5 gig coming in Chicago, 5 gigs coming in Ashburn. The reality is it all comes from China. So wherever your upstreams are peering with China Telecom and China Unicom, and a little bit of Russia too, that's going to be a very heavy ingest point. So from a security standpoint, we work with our carriers and make sure we can always move what we would call source networks. Make sure it's easy from a network standpoint to move that traffic around to places where we either have underused capacity or where we have additional capacity that we've built to handle that kind of stuff. We typically just respond to DDoSes. We typically we haven't seen one yet, knocking on wood, that's been big enough where we really have to start worrying about, okay, how do we block this further upstream of us? So for the most part, our software stack can keep up and our network capacity can keep up. Eventually there comes a point where you're, okay, they've been doing it, we've been getting 100 gigs in for 6 hours. Surely they've now realized that nothing's happening and they're going to stop. Not really. It seems that a lot of it is like, I'm going to do this, and then they go to bed and they wake up the next day to see like, oh, did anything go down? So the longer an attack runs, then we start working with network partners and trying to just kind of limit it.
Is that for cost reasons you're sort of wanting to limit it?
Not really. So again, I assume everybody in the room, if you're a content network, depending on your scale, your inbound is free. Yeah. Assuming you're paying 95th percentile for bandwidth. So for the most part, our attack traffic is free to us. Yeah. We're typically billing our customer for it. So when they start asking us to mitigate, that's when we'll start mitigating as well. Yeah. But we typically just do that in software.
Okay. So the inbound is free, but that sort of for a SYN attack that would be fine, but for an HTTP attack,
that's when we'd reach out to the customer and say, hey, all of a sudden we're doing a ton of outbound, responding to this. Do you want us to keep serving us? Do you want us to mitigate it? And truthfully, from a mitigation standpoint, that's not our core business. That's not what we want to be doing. We don't want to be necessarily a security company first. So we work with partners. We work with Newstar primarily to, if it's going to be an ongoing thing, we kind of integrate the customer, kind of put them in touch with Newstar, and we do kind of combined mitigation that way.
Okay. Cool. Yeah, so I mean, for those of you who don't know, sort of one of the, I think, like best PR events for us ever was, for the Varnish project, was the initial cable dump from WikiLeaks, which had a rather substantial attack launched against it, and was actually quite efficiently mitigated in VCL by basically just, I think they did, like all the attacking clients were using the same, might have an accept language header or the user agent header. There was some sort of signature that was like, yeah, this one is attacking, and then basically they just discarded all those.
Yep.
And that, I think, that was like 20 gigabit attack, which at the time was quite substantial. And for like a 5-man organization that WikiLeaks is, was actually being able to mitigate it was quite cool. Yeah. Could you tell us a bit on sort of the exact reasons for deciding to sort of move your say caching infrastructure to Varnish?
Sure. So 2002 to last year, so 2015, we definitely built up a lot of intellectual debt, to borrow the term of whoever I'm borrowing that from. And truthfully, even the most, what anybody in this room, including myself, would think is the most rudimentary change we would have to make to process, a customer would say, oh, hey, if we get this header, we want this to happen. That involved building binaries for like 7 different distributions of things, and it just became it was easier to just put it on the to-do list than to actually do anything. By the time we went through QA and testing and building and patching, it was just very cumbersome. The stack worked great for what we do, like fundamentally high availability, high throughput delivery. But whenever somebody would ask a very reasonable feature that any sane person running a CDN should say, yes, we can do that, we would say, yes, we can do that. Give us 3.5 weeks, plus or minus, and we'll see if we can get that done. So the main value we saw from Varnish was VCL, vMods, our ability to extend at the protocol level without having to sacrifice availability or cutting down our QA time. So that was the big driving force. And then the second aspect was looking forward 5 years out, 10 years out. Where did we need performance to be? And the reality was, the more we looked at what we were doing for our old stack, it didn't really match up all that well when we were looking at deploying servers with a terabyte of RAM in them or tons of SSDs. It was a legacy architecture in every sense of the word. And so we kind of took a fresh look at, hey, if we were building this today, what would we want it to be on? And the answer was Varnish.
Okay, cool. So are there any sort of things that you're sort of missing from Varnish currently, or that you see that will have to be in Varnish at some point or another?
So HTTP 2 is our big push. We're going to deploy that for our customers sometime this quarter.
Yep.
That's the only glaring thing missing now for us. The reason we ended up going with Varnish Cache as opposed to the open source was the MSE.
Yeah.
So at least under our workload, the open source version basically just didn't work.
Yeah.
And we tried for a few years to see if we could make it tick, and that didn't seem to be an option. So persistence being available now is interesting for us. Right now, today, we don't really restart servers, caches, anything very frequently, if at all. But the ability to do so is attractive. There's probably lots of instances where we could do some sort of rolling restart with persistence that we wouldn't necessarily do today without it.
Yeah. Yeah. Yes. And well, I mean, the thing with persistence is that you don't know ahead of the time if you need it or not.
Right.
Like if you knew it, you sort of probably could have avoided it.
Exactly. So what we do today for that, we do have our architecture. We kind of have a origin shield layer, for lack of a better term. So there's very specific servers in certain POPs that do the ingest from the customer's origin servers. So today, if we have to reboot those or restart them for some reason, we warm them off each other. So we try and keep the load off of the customer's origin. So if we have to reload that ingest point in, say, Ashburn, we'll have Ashburn warm off of Chicago until we get about 60-70% cache hit ratio, and then we'll switch it back to fetching from origin.
Okay, cool. Yeah, so you're already sort of commenting on persistence. So I sort of spent some time reading about sort of CDNs and what they do, and it's kind of hard to talk about CDNs. We're sort of addressing the elephant in that market, which is Akamai.
Who?
Yes. and there was this really interesting event, I think like a quarterly report, which was like 4 months ago, where I think Akamai, the stock took a 20% dive that day as the quarterly report came out, and because out of the top 10, I believe, customers, 3 customers migrated away. They were Comcast, Apple, and perhaps Microsoft, or at least they saw
Disney.
Or Disney, was it Disney? Yeah, Disney. So that all happened in 1 quarter. And this, of course, is, at least we like to say that we sort of predicted this trend, because as like making your CDN is no longer rocket science. It's quite simple, and sometimes it makes sense. So, what I'm curious to sort of to hear your views on the organizations that are now starting to do their own content distribution.
So I kind of have the same answer all the time, which is building a CDN is actually really easy. Certainly, all the pieces are much more accessible in the form of Varnish and AWS, and locating the resources that you need to put it together, infinitely easier than it was even 5 years ago.
Yes.
The challenge always has been, and I think continues to be, running a good CDN. And it's a little bit, and it really depends what performance you need. So we always hang our hat on where are the highest throughput, fastest CDN. But not everybody needs that amount of throughput. So if we look at what we deliver somebody in North America, let's say on Sidexis, our average throughput is 8 megabits a second. If your video bit rate is 2, do you need 8 megabits a second? You certainly don't in perfect network conditions. The question is, what happens if you cut your performance by 50% because somebody's got a fiber cut somewhere? What does 50% look like? Is that enough to drive whatever it is you're driving, whether that's an e-commerce site or video? I think what people do a good job at is just kind of throwing out stuff and saying, okay, I've deployed Varnish here, here, and here. We've got a CDN. I've got some sort of DNS magic going. Okay, great, we've got a CDN. But if you don't know what you're trying to accomplish, it's very tough to know if you did it. So the thing I always encourage people to do is have some sort of stated goal that you're trying to get to, whether that's a page load time that you're measuring with RUM, whether that's a time to first byte number if you do a lot of headers. Whatever you're trying to accomplish, you need to know what that is, and you need to know what that looks like at 6 p.m. on a Friday in New York City, which looks very different than when you're testing it at 3 a.m. in San Jose. Because really, the challenging part about running a CDN for consumer consumption is basically managing your capacity around Netflix, Akamai, Microsoft.
Oh.
Those 3 companies, whether it's me or wherever else you host, those 3 companies directly affect your connectivity to your users. Because if Akamai decides to shift a whole bunch of traffic to Comcast in New York, guess what? Your New York POP sucks. Nothing you can do about it. It's out of your control. They're taking everybody's capacity to Comcast and they're filling it. And they have to. That's the only way they can operate at that scale. It's very much kind of like network whack-a-mole. So it's like, does it fit here? Nope. Does it fit here? Nope. Does it fit there? And so the challenge that you have, they have a different set of challenges, which is those companies are creating the congestion that they're trying to avoid. So they're trying to measure. They go, oh, look, we have all this room to so-and-so here. And they move all their stuff. And like, there's no room to this person here. We need to move it back. What everybody else has to do is kind of bob and weave through what they're doing to make sure that you're getting high performance. So it's very easy to roll out a CDN. It's very easy, especially with Varnish, to roll out the software stack. What's tough is making sure that that's performant during network, either standard network events, so 6 p.m., 7 p.m., 8 p.m. Eastern time when everybody flicks on Netflix, or non-standard events where there's a fiber cut, or there's any sort of connectivity issue between networks. So it's the ongoing operation of, do you want to be running fundamentally a network at that point? So when you've got one set of servers in one data center, it's kind of a mixed blessing. One, the performance might not be that good. But two, there's nothing you can do about it. Even if you wanted to, there's nothing you can do other than maybe opening a ticket with your provider. When all of a sudden you've got 2, 4, 6, 8, 10 data centers to choose from, now you have to optimize 2, 4, 6, 8, 10 data centers. And if you have that number that you're trying to achieve for performance, it's kind of an ongoing thing. It's not like, hey, we set it up and forget about it. Just kind of when you deploy a CDN, you're kind of outsourcing that ongoing management to somebody else. So it makes a lot of sense for a lot of people. But if you want it to be really good, or at least good enough for whatever that number you need, you kind of need to commit some operational resources to care and feeding and making sure stuff works.
Cool. So you just happened to mention the metrics that you use, which we had this discussion during lunch, where I think Matt was making fun of me because of we measure time to first byte as a sort of performance metric for Varnish. And he asked me, so why do I care about time to first byte? And the reason for us is because we can measure it. It's like, and then it sort of, that takes on a life of its own, and it becomes this rather artificial benchmark. So why don't you sort of tell the people here what you told me?
I need my soapbox.
Yeah.
So who here measures time to first byte as part of their kind of normal monitoring anything? Not that many, actually. It's time to first byte is kind of this legacy thing that still kind of sticks around, because at the time when people started using it, it was really the only way to infer what performance you could get out of something. There wasn't really any good RUM system in place. Certainly on aggregate, there was nobody taking billions of measurements of end user performance that people would take today. So it's this very artificial thing that people have in the back of their mind, just as oh God, the first byte needs to be fast, otherwise our site is slow. And I'm specifically making this point as somebody who runs a mostly static object CDN. So when I'm talking about objects, I'm talking about JavaScript, images, CSS, kind of all the building blocks, stuff that you think, oh my God, if that's not loaded, my page is going to block. The time to first paint is affected by time to first byte. And the reality is you're talking about content that doesn't really change all that much. So in a perfect world, you're setting a caching header that's saying, dear web browser, please don't come back and ask me for the CSS for a week, a year, a month. So assuming you're doing that, now the only request you care about is the first one, because there aren't going to be any more. If there were more, you'd typically be doing 304s. So you just have a browser coming back and saying, hey, did this change? No, it didn't. OK. That's time to first byte. Basically, when browsers are coming back and saying, hey, I have this object, here's an if non-match or an if modified since. No, OK, great. For everything else, there's no JavaScript engine that does anything until it gets the very last byte of the JavaScript file. There's nothing that goes, oh, I have half the functions, I guess I'll start executing. There's nothing that renders CSS that way. It goes, oh, I've got half the CSS file, I better start. The only metric that matters for that first paint number is the time to last byte, which is throughput. So that's whenever I hear somebody say time to first byte, time to first byte, very important when you're talking about the infrastructure itself, so the page load. But when you start thinking about objects that are loaded that don't change, it's effectively ping. Yeah. Like I pinged my CDN, therefore it's fast. It doesn't really tell you anything about how that 100 kilobyte, 250 kilobyte file is actually going to download to the end user, going back to what I said, at 6 p.m. on a Friday night. It doesn't tell you about congestion. It doesn't tell you about how fast your page is going to load or paint. It just tells you, it's basically, it's ping, but one further step up the stack.
Yeah.
So ping tells you, OK, the kernel's alive and responded. Time to first byte tells you, OK, your HTTP server is alive and responded. It's really not a great predictor. And there's no studies out there that shows it's a great predictor of anything.
No,
but people.
Like internally, it sort of matters because, I mean, as I said, it's a very easy thing to measure. And because it measures all the things, a lot of the things that are easy to control.
Right.
Like for you guys, when you host your website, time to first byte is sort of dictated by your cache hit rate and basically how well Varnish is running. Like if you have a low cache hit rate, time to first byte will suffer because you need to talk to the app server and the app server is slow. And so, yeah. So, yeah, but it's not the ultimate goal of anything.
Right. It's typically, it's a good metric to track for server health. It's not really a performance metric in terms of what your end users are going to end up consuming.
Exactly. So I wonder, are there any questions from the audience?
Sort of off topic. Well, what are you using for HTTPS? You said you're moving to HTTPS 2.
Yeah. So right now today that looks like Nginx. So we have quite a few tiers of stuff, but that first SSL tier is Nginx. In an ideal world, we'll start to move towards something like Hitch.
If Hitch supports HTTP2.
Exactly.
Soon.
Yes. Yes. So right now, if it was up to us from an engineering standpoint, we'd wait. Right. But quite frankly, everybody wants HTTP2. So we're that'll be our kind of temporary solution, and then we'll migrate to a permanent one.
Yeah. I'm actually really surprised that we got to 2 p.m. without nobody talking about HTTP2 yet.
Which is even next.
For those who are curious, HTTP2 is currently sort of the highest priority task we have. So there's a lot of things not being done because we don't want to delay HTTP2. We expect the first release to be out late September. That has preliminary support for HTTP2. Yes, any other questions? Reza? So, yeah. Let me just repeat the question. So the question was, have you seen any trends regarding SSL uptake lately?
We have. We attempt to price SSL at the equilibrium where it's not too annoying for us to deal with everybody's certificates, but at the same time, if somebody needs it, it's cost effective enough for them to get it. And the reality is we're going to have to switch that to HTTPS has to be really affordable, especially as HTTP2 rolls out, because at this point, it went from a nice to have for most people.
Yeah.
So what we do offer, just take a step back, what we do offer is everybody can get stuff hosted off like a CacheFly wildcard subdomain. So youraccount.cachefly.net over HTTPS, always free, anybody can do it. And that handles about 90% of most people's needs for what they typically are using us for. The other 10% that say we need it on either our domain or our EV cert, whatever their kind of security requirements are, that's the number that we tried to make it just painful enough that not everybody would be like, yeah, give us SSL, give us SSL. And the reality is we have to roll that back because everybody is now saying we're SSL by default. We're getting ready for HTTP2.
Yeah.
So I would say right now today, our total traffic, about 12% of that is SSL. Forecasting that 12 months out, it'll probably be more like 50%.
Okay. So Matt, thank you very much for coming.
Thanks for having me. Take care.